In this second module, we will explore how a microprocessor interacts with the outside world. We will cover interfacing memory and I/O devices, input-output techniques, interrupts, programmable peripheral devices such as the Intel 8255, and timers such as the Intel 8253 and 8254. Section 1. Interfacing memory and I/O devices. For a microprocessor to function, it must connect to memory and input-output devices. Memory interfacing involves connecting memory chips to the CPU. Address allocation and decoding circuits ensure that the correct memory location is accessed. I/O interfacing allows communication with devices such as LEDs, switches, displays, and sensors. There are two approaches. Memory-mapped I/O. I/O devices share the same address space as memory. Isolated I/O. I/O devices have a separate address space. Section 2. Input-output techniques. There are several methods of transferring data between the CPU and I/O devices. CPU-initiated transfers. The CPU actively reads or writes data. These can be unconditional or conditional. Device-initiated transfers, also known as interrupt-driven I/O, where the device signals the CPU when it needs attention. Section 3. Interrupts. Interrupts allow external devices to get the CPU's attention. The 8085 has several interrupt lines, both vectored and non-vectored. Vectored interrupts automatically transfer control to a fixed memory location. Non-vectored interrupts require the external device to provide the address of the routine. Latency time is the delay before the CPU begins handling the interrupt. Response time is how quickly the system completes the service. Handling multiple interrupts requires prioritization and masking techniques. Section 4. Programmable Peripheral Interface, Intel 8255. The Intel 8255 is a widely used programmable peripheral interface chip. Pin configuration includes control signals and 3 ports, Port A, Port B, and Port C. Each port can be configured for input or output. Modes of operation include simple input, output, strobe input, output for handshaking, and bidirection modes. The bit set/reset feature allows individual control of bits in Port C. Programming the 8255 involves writing control words to configure the ports. Section 5. ADC and DAC interfacing. Microprocessors operate in digital form, but the real world is analog. Analog-to-digital converters, ADC, translate analog signals, such as temperature, into digital form. Digital-to-analog converters, DAC, perform the reverse, allowing the microprocessor to control analog devices like motors. Interfacing these chips requires proper timing and control signals to ensure accurate data conversion. Section 6. Programmable Interval Timer, Intel 8253 and 8254. The Intel 8253 and its successor, the 8254, are programmable interval timer chips. Each has 3 independent counters, each capable of operating in several modes. These timers can generate delays, count events, or produce waveforms. The readback command in the 8254 allows the programmer to monitor the status and count values without disturbing operations. End of Module 2 Summary. In this module, we discussed how the microprocessor interfaces with memory and I/O devices, different input-output techniques, the interrupt system, and programmable peripheral devices such as the 8255, 8253, and 8254. We also introduced the role of ADCs and DACs in connecting the microprocessor to the analog world. To conclude, this course on microprocessors has covered both the fundamental architecture and practical interfacing of microcomputer systems. Module 1 provided the foundation, the components of microcomputer systems, semiconductor memories, the Intel 8085 microprocessor, operation cycles, the instruction set, and assembly language basics. Module 2 expanded into practical applications, memory and I/O interfacing, input-output techniques, interrupts, and programmable peripherals including the Intel 8255, 8253, and 8254. With this knowledge, you now have a comprehensive understanding of how microprocessors function, how they communicate, and how they control real-world systems.